In today's video, we're going to look at section 2-4, solving multi-step equations. So all we're going to do today is we're putting everything we know from the last few sections and other chapters and previous years, we're putting it all together now. Okay, so essentially when we solve multi-step equations, we got to think PEMDAS backwards. So when you do arithmetic, you follow PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Well, with solving multi-step equations, we kind of work backwards. We start with getting rid of subtraction and addition first, then division, multiplication, exponents, and then parentheses if there are any. But parentheses, remember, they tell us to work on the inside first. So in essence, we got to work on the outside of the parentheses first. So that's what we got to work on, remember, from now on. Okay, so solving each equation, remember, think PEMDAS backwards. So get rid of addition, subtraction first. So the first thing I'm going to get rid of is that minus 6. And to undo minus 6, I'm going to add 6 to both sides. So I'm left with 2a. Negative 6 plus 6 is cancels out. So I'm left with 4 plus 6, which is 10. Get rid of the division or the multiplication by dividing. And then, so I'm left with a equals 5. And we can do a simple mental check. Plug that back in. 2 times 5 is 10, minus 6 is 4. Okay, so let's do another one. I got 3 more, sorry. But 8 equals 3r plus 7. So first, to get rid of that plus 7, we need to subtract 7. And what we do to one side, we do to the other side of the equal sign. So 8 minus 7 is 1. We're left with 3r. 7 minus 7 is 0. Divide by 3 on both sides to cancel out that multiply by 3, and then just leave it as a fraction because fractions are easier to work with. You don't have to do any division. And so all we're left with is 1/3. Okay, let's do one more. We have t divided by 8 plus 21 is equal to 14. So once again, get rid of that plus 21 by subtracting 21 and subtract 21 again. What we do to one side, we do to the other. So we're left with t over 8 is equal to 14. Oh, sorry, I'm not 14. I forgot to subtract my 21. That's my fault. We actually get negative 7. Then to get rid of that divide by 8, we need to multiply by 8. And what we do to one side, we do to the other. So we get t is equal to negative 56. And there is our solution. Okay, so now we have a different type of looking problem. We have k minus 12 all over 5 is equal to 4. So remember, in previous sections, we talked about when you see that big division bar, it actually has implied parentheses. So you have to get rid of everything on the outside of the parentheses first. So the first thing we need to get rid of is that divide by 5. To get rid of that divide by 5, we're going to multiply by 5. And what we do to one side, we do to the other. So the 5s cancel out. We're left with k minus 12 is equal to 20. And then, to get rid of that, subtract 12, we add 12 to both sides. So all we're left with is k is equal to 32. So remember, we have implied parentheses when we have that big division bar. Let's do another one. N plus 1 divided by negative 2 is equal to 15. So remember, we have implied parentheses on the top. So work everything outside the parentheses first. So first things first, we got to get rid of that division by negative 2. So we're going to multiply by negative 2. And what we do to one side, we do to the other side of the equal sign. So we're left with n plus 1 is equal to negative 30. Get rid of that plus 1, we're going to subtract 1 from both sides. So we're left with n is equal to negative 31. Okay, so we're still following the same rules, working PEMDAS backwards. All right, Hugo is buying a pair of water skis that are on sale for 2/3 of the original price. And I'm going to call original price P. Okay, after he uses a $25 gift certificate, the total cost before taxes is $115. What was the original price? Okay, so write a equation and then solve. So think of it. It is on sale for 2/3 of, so we're translating the original price P. But then he's taking off another one. So if you take off some money, that's going to be subtracting $25, and he ends up paying only $115. So we need to solve how much the original price is. So now we're at a normal problem. First, we're going to add 25 to both sides to cancel out that subtract 25. So 25's cancel out. So we're left with 2/3 P is equal to 140. Now remember we talked about when you see multiply by a fraction, you can multiply by its reciprocal to cancel it out instead of having to divide. So I'm going to multiply by 3/2 on both sides. And remember, reciprocals cancel each other out. So all we're left with is P is equal to, now I'm going to do a little fractional work here. Okay, so I'm going to reduce here. That goes to 1. That goes to 70. So all we're left with is 70 times 3, which is 210. So the original price was $210. So that's a pretty good amount he got off. He got off almost $100 of the original price. Okay, so next, last thing we're going to talk about is consecutive integers. And this is just to help us translate. Integers in counting order. Okay, so 1, 2, 3, 4. So numbers in order is essentially what it's saying. So then, here's some more. Consecutive even integers are -4, -2, 0, 2, 4, 6, 8, 10, and so on. And then the consecutive odd integers, -3, -1, 1, 3, 5. Now, notice, when we have consecutive integers, for instance, it's 0, 1, 2, 3, 4, 5, and so on. Okay, we got to keep in mind that as consecutive integers, it's always adding 1. It's always adding 1, and so on. Consecutive even integers and consecutive odd integers, they are adding 2 every time. So that's going to help us identify how to solve the next problems. Okay, so keep that in mind. So find 3 consecutive even integers whose sum is -42. So think of that. We don't know any of the 3 integers, but it's saying consecutive even integers. So if I have my first integer, my next one is going to be whatever that integer is plus 2. And then my next integer is going to be whatever that one is, whatever that previous one is, plus 2. So it's actually going to be n plus 2 plus 2. Or plus 4. Okay, so those are my 3 integers. My 3 integers I'm looking for are n plus 2, and n plus 4. So now, I want to know what those integers are, but I know some more information. The sum of those 3 is equal to -42. So I have n plus 2 plus n plus 4. Those are the 3 integers. Okay, so that's where they came from. And those are equal to sum of -42. So now I'm going to go back to what we've learned in the past and combine like terms. Okay, so we combine like terms. N plus n would be 3n. 2 plus 4 would be 6 is equal to -42. So now I'm at a basic problem that I've worked on in the last few slides. Cancel out that plus 6, subtract 6 from both sides. So we get 3n is equal to -48. Solve for n, divide by 3 on both sides. So we get n is equal to -16. Now that's the first one. So I get -16 here. But then I got to add 2, so I get -14. And then I got to add another 2, or 4 from the original, and I get -12. So my answers, my 3 consecutive even integers, are -16, -14, and -12.